Example 8. How long will it take money to triple if it is invested at 5% compounded daily? Assume a 365-day year. Okay. We first saw this problem, I believe it is example 5G, if we flip back to that. Okay, so this is going to be example 5G. So let's go back and take a look at that. Okay, here it is right here. Okay, on page 4. Okay, so here it is. How long will it take money to triple if it is invested at 5% compounded daily? When we went through example 5, we labeled this particular problem as a compound interest problem. Okay, so let's go back and talk about why we decided this, and then we'll go ahead and work the problem. Okay, so here we go. You have some money. Okay, the tricky thing for this problem is you don't know how much money you're investing. Okay, that's not stated. Okay, so whatever money you have, you're trying to figure out if you invest it at 5% compounded daily, how long is it going to take that money to triple? Okay, so as far as why this is a compound interest problem, okay, when you read the problem, it is pretty much implied that you are investing a one lump sum. Okay, however much money you have, that one lump sum, how long is it going to take to triple? Okay, so this money, it is implied that this is a one lump sum. All right, so that makes this, oops, what happened here? That makes this compound interest. Okay, all right, so let's go ahead and write down what we're going to use. Okay, we're going to be using our compound interest formula. So let's figure out what we're looking for and the value of all the other variables, and then we'll try to solve. Okay, all right, first thing when you read, okay, is how long will it take? Okay, as soon as you read that, how long will it take? That's implying that you're looking for time. Okay, so we are looking for time here. Okay, notice that time is in the exponent. It's part of the power. The power is m times t. Okay, because time is in the exponent here, it is going to be super tricky to solve for time. Okay, but I am going to walk you through the steps of how to do this. Okay, but just hang tight, but keep in mind it's going to be a little bit tricky. All right, let's see what else we know. We should know the value of all the other variables. Okay, if you read through, the R value is 5%, so convert that to a decimal, it's going to be 0.05. Okay, we are compounding the money daily, and so we're going to assume a 365-day year, so M is going to be 365. Okay, and then if you look at the formula, we're missing P and A, and like we've already stated, there's no other numbers in the problem, so that makes this a bit tricky. Okay, if you remember how this formula works as far as P and A are concerned, okay, remember P is the amount of the one lump sum that you're depositing, and then A is the account balance, okay, or the future value, okay? So this is how we're going to handle this since we don't have a specific value of money that we're going to invest, okay? All you have to do with a problem like this where it's not stated is make up a number, okay? It's going to work. So I'm going to keep it simple. Let's say I'm going to initially deposit $100, okay? You can pick anything you want, okay? And I'll show you that later in the video. It will work no matter what you pick, okay? Well, if I choose to invest $100, okay, I'm interested in how long it's going to take the money to triple or be multiplied by 3, okay? So you're hoping for a future value of 100 times 3, okay, if that money triples, which is $300, okay? So that's what you would, if you chose P to be 100, then A would be 300, okay? So now we're going to go ahead and we're going to plug all of this into our formula, okay? So we're going to get 300 is equal to 100 times 1 plus R over M raised to the M times T power. And T is what we're looking for, so we're just going to leave it as a variable, okay? So this is how you set it up and you have to solve for t. Again, very tricky because t is in the power or the exponent, okay? We did not have this issue when we solved simple interest problems for time because simple interest formulas, you know, there were no exponents involved, okay? So here we go, okay? Let's talk about how you would solve something like this, okay? Meaning how do you deal with the variable being in the exponent, okay? So this is how we're going to do this, okay? And you're going to see this with the other formulas, okay? The remaining formulas, all the formulas besides simple interest have t in the exponent. So if you are solving for time, you're going to have to take steps similar to what we're about to do to solve for time. Okay, so this is something called an exponential equation, meaning you're looking for t, t is trapped in the exponent. So essentially, in order to solve for t, we are going to have to get t out of the exponent or out of the power, okay? And the way we do that is by using something called a logarithm, okay? So maybe you've seen a logarithm before in algebra, okay? Maybe you haven't, okay? I know when I was in school, I never learned logarithms, okay? So maybe you've seen it, maybe you've not. If you've seen them before, you know, it might help you. If you haven't seen a logarithm before, do not panic. I'm going to walk you through the steps, okay? Let me show you really quick what a logarithm looks, well, just to kind of familiarize you with a logarithm. If you take a look at a calculator, okay, there are actually lots and lots of types of logarithms, but there are two very popular logarithms, and they can be seen as buttons on your calculator. If you look at your calculator, there's an LOG button and there's an LN button. And those are two very popular types of logarithms, LOG and LN. Okay, so let me go back and kind of jot this down. Okay, so there's LOG and there's LN. Okay, so again, those are just two types of logarithms. And what a logarithm is, it's an operation. If you take the logarithm of a number, okay, it does something to that number. Okay, so the difference between these two, and I'm not going to go into great detail, but logarithms have different bases. Okay, LOG is a base 10 logarithm and LN is a base E logarithm. Maybe you've heard of the number E. E is a number like pi. It's approximately 2.71. We are going to talk about it a little bit later in chapter 3. Okay, so again, if you're not familiar with it, don't panic. But the point is, logarithms have bases, and LOG and LN are just basically different because they have different bases. Okay, and that's kind of what differentiates different types of logarithms from one another. They just have different bases. Okay, for the purposes of our class, we are just going to use LN, which is the natural logarithm. Okay, we are going to use this one for everything we do. Okay, so in your calculator, you're going to want to familiarize yourself with the LN button. Okay, so LOG could work, but we're just going to stay consistent with one of the types of logarithms to make it less confusing. Okay, all right, so basically, the reason we're going to use logarithms is because that is the tool we use to get the variable out of the exponent. Okay, all right, so let's get back to our problem and talk about how this is going to work. Okay, I'm going to go ahead and erase this. Okay, because you need, when you're solving these time problems, you're going to need a lot of room. Okay, all right, so here we go. Here's the setup. We're trying to solve for t. Okay, eventually we're going to use a logarithm, not just yet. Okay, the very first thing you're going to want to do is isolate the thing that contains the exponent. Okay, so I'll write this down. First thing we're going to do is isolate the thing that contains the exponent. Okay, when I look at the right side of this equation, okay, what is being raised to the 365 times t power? Okay, well, this thing in parentheses is what's being raised to the power. Okay, the 100 in front is not being raised to the power. the 100 is outside of the parentheses. Only the stuff that is in parentheses is being raised to the power, okay? So essentially, this quantity in parentheses with the exponent, I want to get it by itself. I need to isolate that, okay? That is my first step, okay? So what we're going to do, okay, I am going to go, oops, I erased too much. I am going to rewrite, okay, what I have, okay, because I don't want to do too many steps at once and confuse you, okay? Like I said, when you're doing this kind of stuff, there's a lot of steps involved, and if you try to do everything at once, you will probably make a mistake, okay? So one step at a time, okay? We're going to isolate this thing that I have boxed in red, okay? So we need to get rid of the 100 that's out front, okay? The quantity that's in the box here, this stuff in parentheses raised to the power, it's being multiplied by 100. So to undo that, we're going to divide by 100, okay? If you do it to the right side, you need to do it to the left side, okay? So what's going to happen on the right side, 100 divided by 100, those are going to cancel, okay? And so what that's going to leave you with is 300 divided by 100 is 3 is equal to the quantity in parentheses raised to the 365 times t power, okay? So now we have done this first step. We have isolated the thing that contains the exponent, okay? All right, so carrying on, what do you do next? Okay, so once you have the thing that contains the exponent isolated, now you are going to take the logarithm of both sides. Okay, and like I said, we are going to use ln. Okay, all right, so let's do it, okay? Like I told you, the logarithm, it is an operator. It operates on a number, okay? So when you take the logarithm, it has to go on the left side, okay? It doesn't make sense to go on the right side, okay? So I'm going to take the logarithm of the left side. Whatever you do to one side, you have to do to the other, okay? So it's going to look like this. All right, so we've just taken the logarithm of both sides, okay? At this point, you may be wondering, hey, can I go ahead and simplify this quantity that's in parentheses, the 1 plus 0.05 divided by 365? You can. It's just going to give you an outrageous decimal, and you're going to have to carry all the digits. So I wouldn't even worry about that. I would just leave it like it is, okay? But if you want to, it doesn't really change anything, okay? All right, so we have taken the logarithm of both sides. Again, the logarithm has to be on the left side, okay? And let me show you why really quickly, okay? If, like I said, the logarithm does something to a number. You, on the left side, you took the natural log of 3, okay? It changes 3 into a yucky decimal, okay? If I had done the reverse and I did 3 natural log, that doesn't make sense. It gives you an error, okay? So again, a logarithm is an operator, okay? It changes a number into some other quantity, okay? All right, so here's where we have left off, okay? Now here's why this works, okay? And again, if you've never seen logarithms before, this is gonna be unfamiliar to you, okay? There is this property, okay? So I'm gonna write it, I'll put it right here, okay? We're going to apply this property, okay? If you are dealing with any type of logarithm, there's this property that says, I'll just put natural log because that's what we're working with. If you have the natural log of something to a power, you are allowed to take the power and bring it down, okay? So this is going to become the power times the natural log of the something. Okay, so again, the natural log of something to a power is equal to the power times the natural log of the something. Okay, so how that helps us here, okay, look at what we have on the right side. Okay, on the right side of our equation, we have the natural log of something to a power. Okay, this property is saying we are allowed to take our power and bring it down in front, okay? So that's what we're gonna do in the next step, okay? All right, so I'm running out of room, okay, so I'm gonna have to erase this. I will go ahead and, let me erase this, and I'm gonna move up here. Okay, I will rewrite that property up at the top. Okay, let me go ahead and do that. Okay, so the property we're looking at, okay, so I'll say apply property of logarithms. Okay, so here we go. Just jot this down. And I'll rewrite those steps up here later before I post this. Okay, all right, so in the next step, like I said, we have the logarithm of something to a power. We're gonna bring the power down on the right side. Okay, so draw an arrow so you can follow where I'm going, okay? Nothing happens to the left side. It's still gonna stay the natural log of 3, okay? So then on the right side, we're going to go ahead and bring down that power, okay? So the right side is going to become 365 times t times the natural log of 1 plus 0.05 divided by 365, okay? So this is powerful. The t, that's what we're solving for, it is now out of the exponent, okay? And so we can solve for it, okay? All right, so here we go. T is the only variable present, okay? Everything else is just a number, so we're gonna be able to solve for t, okay? Here's the thing. Do you guys remember, I think it was at the bottom of page 5, I told you there was a little note about time and that we would talk about it when we got to a time problem, okay? So here we are, solving for time, okay? We're actually not gonna solve for t, we're actually gonna solve for ilm times t. Okay, so remember in our case right now, ilm is 365. So instead of solving this equation for t, we're gonna solve it for 365t. Okay, so if you look at this, natural log of 3 is just a number. If you remember, we plugged that into the calculator a couple minutes ago and we got this nasty decimal, but that is just a number. And then if you took this natural log of 1 plus 0.05 divided by 365, and if you plop that into the calculator, that is going to be another nasty decimal, okay? So this right here is just a number, okay? So if you want to solve for 365t, all you have to do, since you're multiplying 365t by this logarithm, you just need to divide it off, okay? So what we're going to do, okay, to get 365t by itself, we're going to divide by this logarithm, okay? And whatever you do to one side, you have to do to the other. So you're going to have to divide this logarithm on the other side, okay? All right, so then on the right side, this logarithm would cancel with this logarithm, okay? And so then 365 times t would be equal to, and I'm just rewriting this for your notes, 365t is equal to the division of these two logarithms, okay? All right, so we're almost there, okay? So let's go ahead and we're going to go to our calculator and we're going to punch this in. It is one logarithm divided by another, okay? All right, so here we go. So we're going to have the natural log of 3, close parentheses, divided by the natural log of 1 plus 0.05 divided by 365, close parentheses, okay? That is how you enter this in. Hit enter, it's going to give us a nasty decimal, okay? And then we're going to go back to our notes and make sense of this answer. Remember, you are solving for time. This is not a dollars and cents amount, okay? All right, so let's go look at it. Okay, so this is going to be, okay, 365t is equal to this decimal, 8,020.418,999, okay? All right, so this is a time value, okay? Let's go ahead and flip back to that note on page 5, okay, when we were solving for time, Okay, if you go back down here, okay, this is what we skipped and I said we would come back to. Okay. It goes through and it says if the compounding is monthly, stop when you find 12t. If it's quarterly, stop when you find 4t. If it's weekly, stop when you find 52t. We did that. We're doing ours daily, and we stopped when we solved for 365t. Okay. But then look at this statement in bold. This is very important. Okay. Okay, so it says once you get your number, we just got our number, the 8020 number. Okay. It says no matter what, you're going to round up to the next whole number of periods to ensure that the needed amount of time has passed to accomplish what you're trying to do. Okay. So when solving for time, you need to round up to the next whole number, no matter what, just to ensure enough time has passed to accomplish what you're trying to do. Okay. So what you would do at this point, okay, think about the rounding here. Okay. 8020, 0.4, that's a 4. So usually you would keep it as 8020, okay? But you're going to round it up to 8021 to make sure that you have had enough time has passed to accomplish what you're trying to do. Okay, so this is going to be 8021 is equal to 365t. Okay, and I'm sure you're wondering, where is this going? Okay, at this point, why did we keep the 365 around? Okay, the 365 in front of the t is indicating that we are talking about days. Okay, so it's going to take 8,021 days for the money to triple. Okay, so that's the answer. Okay, the question asked, how long is it going to take the money to triple? 8,021 days. Okay, of course, days are hard for us to process. Okay, so this is an acceptable answer. If you wanted to make more sense of it and talk about it in years and leftover days, maybe that's easier for you to process. So I will go and do that. Okay. But again, if you look at the question, it just says, how long will it take? It doesn't say, give me the answer in days or give me the answer in years and leftover days. It's not specific. So as long as you give a correct answer, that is fine. Okay, so what we're going to do is try to make more sense of this 8,021 days. Okay, I'm going to do that over here. Okay, but again, 8,021, that is a sufficient answer. Okay, I am going to convert this to days. Okay, years and leftover days. Okay, so this is where we left off. Okay, we're going to go ahead and divide by the 365. Okay, so if you do that, okay, that's going to let you solve, that's going to allow you to get a t value out of here. Okay, so t is going to be, let's see, if you go to your calculator and you do 8,021 divided by 365, okay, this is going to give you this decimal. So let's talk about that. Okay, so I'm going to go ahead and jot that down. So it's going to be this nasty decimal. Okay, so now it's solved for t. There's no 365 in front. Okay, so remember, t is measured in years. Okay, so this whole part right here is telling us 21 years. Okay, and then some. This decimal is very close to 22, so it's very, very, very close to 22 years. Okay, so what we're going to do is take this decimal part and convert it into the remaining number of days. Okay, so here we go. Okay, so we're going to say, okay, 21 years, 21 whole years. Okay, how many days are in 21 years? Okay, so we're going to do 365 days in 1 year times 21 years. Okay, what's that going to give us? 365 times 21. Okay, so that's 7,665 days in 21 years. Okay. Okay. So then we know it's going to take us 8,021 days to triple the money. Okay. So we can subtract that out. So 8,021 minus 7,665. Okay. That's going to give us, let's see here. That's going to give us 8,021 minus 7,665. Okay, 356 remaining days. Okay, so this is 356. Okay, so another appropriate answer instead of 8,021 days, which is kind of hard to process. Okay, 21 years, 356 days. Okay, these are equivalent answers in red. Okay, either one would be acceptable. Okay, but that's how long it would take this money to triple, so quite a while. Okay, and this is your first time solving for time. Okay, so you got to use the logarithm. You've got to go through this process. Okay, we're going to try another one. Okay, in the next example. But before we do that, I did want to clarify to you as to, in the beginning, we used a random amount of money. We did $100 and then we had it triple to be 300 and the problem worked out. Like I said, you could have used anything. Okay, so let's come back to the initial setup. Say I had chosen $500 instead, or sorry, let's make it 5,000. Okay, if that were my initial amount of money that I was going to invest, then you would have said, okay, triple the money. And so that would have been 15,000. Okay. And so then when you plugged in here to the initial setup, okay, your first step would have been dividing the 5,000 off. Okay. And so you would have ended up right here. It would have been 15,000 divided by 5,000. And that would have given you the 3 right here. Okay. So then the problem would have proceeded just like this other problem with 100 and 300. Okay, so that's why it doesn't matter what you use as your initial investment. Okay, all right, let's try example 9, another time problem.